Hello students, this video is to help review with the interim assessment 2 cumulative review. This is part 1 of 2 different videos because it was just too long of a packet, couldn't do it in 2 videos. Alright, hopefully you tried these questions already. If you haven't already done so, please pause the video, try these out, and then come back to see if you got them right. Okay, as you can see, this is a review for units 1 through 3. A lot of things that we learned about in units 1 through 3 are repeating all throughout all the units, so it's very important for you to go back and make sure you remember some of those things. For example, the distance formula. The line segment has endpoints 3, -5, and 9. 3, you need to memorize this distance formula. It will not be on the formula sheet. You substitute the values in and solve, you get d is equal to 10. A common student misconception would be the square root of 100. Students might say that the answer is square root of 10 because 10 times 10 is equal to 100. But once you do the square root, you do not have to write the square root again. So the square root of 100 is just simply 10. For question number 2, notice I did not use the grid. You could have used the grid and a slope method. I used a different method, which is called the partition formula. This is another formula you have to memorize. The way you get the x value is using this formula, and the way you get the y values using this formula. Notice that the formulas are exactly the same, except the x value has all x's, the y value has all y's. In any event, you substitute and solve, you get 0, 11. This is really an algebra problem. I'm going to show you the graphing method or the slope method now. Okay, you can see that I graphed point R and point W on the graph here. This was a weird graph, especially for these points, because 6, 20 is hard to graph on a standard graph, so I had to move my axes all the way down here. This is my x-axis and my y-axis. I graphed R and W, and I showed that the slope from R to W is up 3 over 2. It's 3 halves. And I go 1, 2, 3, 4, 5 times using that up 3 over 2 method, or up 3 over 2 pattern. I'm asked to find a point that splits the line segment into 2 to 3. That means 2 slopes on the left-hand side and 3 slopes on the right-hand side. This point is the point that I'm looking for, and if you counted it out the boxes, the x value would be 0 and the y value would be 11. So I could have gotten the answer either way. For question number 3, I was not given a graph, so that's why I try to ask you to use the partition formula. The partition formula is always going to work regardless of whether you have a graph or not. In this case, the y value in the partition formula is going to be a decimal. Don't be afraid, decimals are people too. -1, 2.5 is the value of p. For number 4, it's asking the slope of a line that's perpendicular to the line whose equation is 6x plus 5y is equal to 4. This form here is called standard form of a linear equation. In order to find the slope, we're going to solve it to put it into slope-intercept form. I did that here. This is an algebra skill, so you should know how to do this. So my slope is -6 over 5. I'm asked for the slope of a line that is perpendicular, and anytime you think perpendicular, you should think negative reciprocal slope. The negative reciprocal means I flip the fraction upside down, and I turn it from whatever sign it is to the opposite sign. So this is a negative fraction. I turn it to positive. 6 over 5 becomes 5 over 6, and I'm done. Take a look at the second page, starting from question number 5. If you haven't already done so, try these questions, and then see if you got them right. Here's question number 5. It asks us to write an equation. Remember, the equation of a line should be y equals mx plus b. That represents the perpendicular bisector. Perpendicular, of course, meaning negative reciprocal slope, as we talked about just before. And a bisector, I'm looking for the midpoint. I'm given the endpoints, which are x1, y1, x2, y2. I label those so that I can use my formulas for them, and then I get started. The slope is a formula that you will not get on the formula sheet, so please memorize that. Simplifying this, I get -1 over 2, and then I'm asked to find a perpendicular line. So perpendicular means I need a negative reciprocal slope. So -1 over 2 becomes +2 over 1, which is the same as saying 2. Now, finding the midpoint, I have to do that because it asks for a bisector. The midpoint formula, again, is not going to be on the formula sheet, so memorize that. Here's my midpoint formula, which simplifies down to 0, 3. That means this value is my x value. This value is my y value. A perpendicular bisector needs not just a slope, which I get from perpendicular, but I also need a point, and that point is going to be my midpoint. So x and y. In order to find my y-intercept, I substitute x and y into my y equals mx plus b formula, including the slope that we found before, which was 2. I put it in there. And then x, y, 0, 3, I put it in here. I solved to get the y-intercept, so now I have all the information that I need in order to write my equation. I have my y-intercept, which is 3. and my slope, which is 2. This is a 4-step procedure, and it may very well be a 4-point question on your interim assessment. For number 6, a triangle is drawn with these angles. Anytime it asks you to work with a triangle, but it doesn't give you a triangle, you might as well just draw any triangle and label it. So here are my 3 angles. I've labeled the angle measurements here in terms of x, and it asks me for the measure of the largest angle in degrees. So I'm going to use the triangle sum theorem. I have all 3 angles here. I don't know their actual measures, but I do know their measures in terms of x. So I'm supposed to say that these 3 angles add together to give me 180 degrees. So I substituted x plus 10, and 2x minus 6 into this equation. Then I simplified even more, and I solved for x. So x is equal to 44. Keep in mind, we have to identify what the question is asking us to find. It's asking us to find the value of the largest angle, not just the value of x. So now that I have the value of x, you can see here that I substituted x for 44, substituted x for 44, and substituted x for 44. This angle is 44 degrees, this angle is 54 degrees, and this angle is 82 degrees. It was asking for the largest angle, so the largest angle, of course, would be 82 degrees. For question number 7, there are a lot of different statements here, and we have to determine which of the statements is true. In order to figure that out, we labeled the picture with all of these measurements, the 35 degrees, 30 degrees, and 60 degrees, and then you can see all of the different steps that I took in order to find the other angles. For example, once I knew that this angle was 35 and this angle was 30, I used the triangle sum theorem to find this last angle. You can see my method down here. If you're not quite sure of how to do that, pause the video and try to parse through it. And then if you're still not sure, please try to ask me during extra help on Tuesday. Supplementary angles is the next thing. I know this angle is 115 degrees, so the angle that is next to it that forms a linear pair with it is going to be 65 degrees. Then I already know this 60 degree angle from the givens, so 60 and 65 together, that's 125. That means that my remaining angle here has to add to 125 to give me 180. That means that angle must be 55. Last but not least, I'm asked a couple of questions about triangle ABC, which means I need angle A, B, C. That means this angle's 30, this angle's 55. The angle addition postulate allows me to add 2 angles together and get the larger angle, so 30 plus 55 is 85 degrees. The first one says the measure of angle ABC is obtuse. Well, no, it's not. There's no angles in this triangle ABC that are larger than 90 degrees. The measure of angle ABC is actually 85 degrees, so that's not correct. This says triangle BCD is equilateral. I don't think that's true because angle BCD is 60, but angle BDC is 65. If it were an equilateral triangle, that means all of the angles would be 60 degrees. This says ABC is scalene. Scalene means that all angles are different. Well, that's true because all angles in ABC are different. This angle is 85, this angle is 35, and this angle is 60. If it were something other than scalene, if it were, for example, equilateral, then all the angles would be equal. Or if it was isosceles, then 2 of the angles would be equal. We'll get to that later. This says the measure of angle ABD is 85 degrees, but that's not true because angle ABD is here. That angle, of course, is 30 degrees, not 85 degrees. This says triangle ABD is isosceles. ABD is this triangle that's here. I see this angle is 30, this angle is 35, and this angle is 115. Isosceles means 2 angles are congruent, but all angles are different here, so that's no good. And then last but not least, triangle ABC is obtuse right. Well, triangle ABC is neither obtuse nor right. Triangle ABC has these 3 angles, which means there are no right angles. And of course, obtuse means one of the angles is larger than 90 degrees. So unfortunately, that is not correct either. All right, for question number 8, we're told that ABC is equilateral triangle. And we're also told that AD is equal to AB. What I did here, instead of listing out my theorems the way I did for number 7, I tried to do it in order in terms of my logical argument. So hopefully you can follow along here with the colors. The first color statement says if ABC is equilateral, then all of its sides are congruent. So I labeled that in red. Next, I said, well, if ABC is equilateral, then all of its angles must be congruent. So I labeled all of those in blue. All of those angles should be 60 degrees. Next, I can figure out that this angle is 120. DAB and BAC, which is this angle here and this angle here, they form a straight line, so the angles add up to 180. That means if this is 60, this is 120. That was in green. Next, in purple, if AD is equal to AB, that's this line here and this line here. That means that DAB, this angle on the side here, this triangle on the side, is an isosceles triangle. which means that this angle and this angle have to be equal to each other. I don't know their measurements yet, but I know they're equal to each other. So this is x degrees, so this must be x degrees. Then finally, I know that DAB is a triangle, this triangle DAB, this leaning triangle here. So that means its angles must add up to 180. So angle BDA and angle DBA are both 30, because 30 plus 120 is equal to, you guessed it, 180. We're on the third page. This is the last page that we're going to deal with in the video. So pause the video, try to answer these questions, and then see if you got them right. All right, for this question, question number 9, it says that AB is extended to point D. Anytime you see the word extended, you should start thinking exterior angles. And in fact, this is an exterior angle. The exterior angle theorem states that these two angles that are on the inside, we call these the remote interior angles, are equal to the exterior angle. That's the angle out here. So I substituted into the equation. I simplified and I solved for x. X is equal to 25. But again, this question is not asking for the value of x. It's asking for the measure of angle CAB. So I substituted x into all of my values here. I didn't need to substitute into all of them, but I'm showing you how cool math is. The measure of angle CAB is 25 plus 40. There's x plus 40. That's 65 degrees all told. For question number 10, it is a minimum degree of rotation question, also known as a minimum angle of rotation question. It tells me a regular hexagon with n equals 6, that means 6 sides, is rotated in a counterclockwise direction. If I'm rotating in a counterclockwise direction, that means I'm looking for the minimum number of degrees of rotation, so it'll coincide with itself. Coincide with itself is the same as carry onto itself. It's the same as map onto itself. It's the same as completely overlap. All of these phrases mean I'm trying to take a hexagon and turn it around until it completely covers itself so that it's overlapping. I drew out a hexagon here as an example. I'm going to try to take this hexagon and rotate it counterclockwise. That means to the left here. I'm going to try to rotate it until, boom, it coincides with itself, or it maps onto itself, or it completely overlaps. In order to figure out the number of degrees there, I have a formula. This formula is not on the formula sheet. Keep in mind that the formula sheet is really not super designed for this section of geometry. It's really designed for the second section of geometry when we talk about volumes and all that. But anyway, the formula sheet doesn't have this. So you remember 360 divided by n. In this case, n is equal to 6, so that angle is equal to 60 degrees. If the question were to ask you to identify all angles of rotation, then you're supposed to add the angle to itself stopping at 360. So I got 60 degrees, so the answers are going to be 60, 120, 180, adding 60 every time, 240, 300, but I stop at 360. Anytime I take any shape and rotate it 360 degrees, it maps onto itself, so that's not a special number of degrees of rotation. It's true for any shape. For question number 11, it tells me the endpoints of B and C, and then it asks me to transform it with a rotation of 90 degrees. Rotation of 90 degrees, that is a rule that you have to remember. The rotation of 90 takes x comma y and turns it into negative y comma x, which means 5 comma 1 becomes negative 1. I changed the y to its opposite sign, and 5. I took the x and I put it in the back. Same thing here, negative 3 comma negative 2 is turns into 2, which means I changed the sign of the y value, and negative 3. I kept the sign of the x value the same, but I just moved it to the back. And last but not least for this video, it asks for the coordinates of p prime, which is the image of p, negative 4 comma 0, under this translation. This translation is written out as a vector. It tells us to take the x value in mind and subtract 3 from it, and then take the y value and add 6 to it, which means I'm going to take negative 4 and subtract 3 from it, giving me negative 7, and I'm going to take 0 and add 6 to it, giving me 6. That's the answer for that one. All right, this was the video on the cumulative review for the interim assessment number 2. Please stay tuned for the next half of the video, and as always, good luck studying.